In schools, we don't so much have an energy crisis as we have an energy waste crisis. We've all seen and heard of schools that either can't afford to turn the heating on or can't afford teaching resources because of the rising cost of energy. Most schools operate with a performance gap. This is the difference between how much energy they were designed to consume and how much energy they actually consume. This gap could be as much as double in our experience.
Drift is a gradual change in the quality of the building's operation over time. There can be many causes for performance drift, but is more often than not caused by poor management of the hydronic circuit. So initially at the design stage, there can be poor consideration for oversizing pipework, undersizing insulation. If we look at bypass control throughout the circuits, especially when we could look at heating circuits, we don't want to be circulating water, or at least hot water, 24 hours a day when we can control it better. If we look at the way that we control the terminal units, so we look at thermostatic control, are those thermostatic controls presettable? Are we making sure we're using the right valves, whether it be a constant volume system or a variable volume system? We installed plant 20 years ago, but are we making sure we're recommissioning as we're adding components into the circuits? We need to make sure that we're not circulating hot water continually 24 hours a day when we've got, let's say, school hours. If we are going to circulate hot water, we're insulating that pipework. But even better, we can decentralise the hot water. We can add a HRU at the location of the outlet, and maybe we feed that from the heating circuit. And rather than flowing hot water continually, we can lower those temperatures because Legionella is less of an issue. Rather than having two pipes hot, we can have the flow pipe warm. And of course, because we're using the HRU, the return pipe's going to be much cooler. And of course, we're not running at too hot temperatures. We're not circulating at, let's say, 65 to pasteurise the secondary hot water loop, and then maybe fitting a TMV to cool it back down. We're able just to keep those temperatures a lot cooler because we're using a plated exchanger rather than centralised hot water. What we're seeing is we're seeing a shift from FM companies not just maintaining systems, but actually using tangible data to make benefits. So taking data on board from plant rooms and actually hitting efficiency thresholds where they're saving their client money by the operation of the plant, not just CapEx.